the moment of inertia of an elliptical disk of uniform mass distribution of mass m, major axis r and minor axis d, about its axis is. So we have an ellipse. Okay, ellipse is like this. We have a major axis which is of distance r. Okay, and the minor axis which is of distance d. Right, major axis of r and minor axis of d. Okay, about its axis. So what will be the moment of inertia? See, moment of inertia of a disk. See, this is the major axis r. Okay, major axis r and minor axis is d. Right. So now, if I want to find out the moment of inertia of this particular disk, I have to compare it with mr square by 2 and md square by 2 and so on. Now let's have a look at this figure. Okay, suppose I make a disk of radius r disk. It will look like this. Okay, obviously it is bigger than this elliptical disk, and more mass is there, more mass will be there in that. So then the moment of inertia of that disk will be greater than this elliptical disk. So obviously it is less than mr square by 2. So this option is correct. This option is correct. Now if I take md square by 2, see, I want to compare it with md square by 2. Suppose there is a md square by 2. So md square by 2 disk will be of this size. Now this md square by 2 moment of inertia obviously is lesser than this disk. So this is more than md square by 2. So if this option was greater than md square by 2, it would have been correct. But there is not such an option. So this less than mr square by 2 is the correct option.